Studies Section 15. Use of computer in data analysis. Introduction. Our discussion up to date has been centered on using manual calculators, pen and sheets of paper in estimating parameter values. However, if we have a large volume of data before us, which is usually the case with survey research, it may be tedious to use manual calculators. Thus, in this chapter, we introduce the use of computer in data analysis. Objectives. After studying this lecture, you should be able to 1. Prepare a good questionnaire for surveys research. 2. Code information collected by the questionnaire method. 3. Prepare data for analysis and use a computer package to analyze your data. Pretest. 1. List out 3 benefits of the use of computer in data analysis. 2. Outline the various steps involved in a qualitative research. 3. Describe how you would gain access into an SPXS worksheet. Content. Section 1. Setting the stage. Let me remind you of some principles we discussed in the earlier part of this course. We discussed that in any qualitative research work, it is always rewarding to have specific guidelines for the research to be meaningful. Many scholars have suggested the following basic steps in a qualitative research. See Alan Bryman and Duncan Grammer, 1997, page 3. Theory. Hypothesis. Operationalization of concepts. Survey. Data collection. Analysis. Findings. See Farmer, SP 1975. The starting point is the theory. The next stage is the setting up of relevant hypotheses. The hypotheses are propositional statements, hence they are made up of concepts. These concepts must be measured. You must develop measures for these concepts, that is, operationalize them. A faulty operational definition will produce a wrong measure. You may do a pre-survey test to try your measure. Then you go out to the field to conduct your survey by carefully selecting your sample. Collect your data through the various devices we have discussed in this course. Before the data can be analyzed, it must be prepared in a computer-ready format, that is, coding. This stage will be discussed further in this lecture. The result of your analysis will validate or disprove your hypothesis. Thus, your findings can then be fed back into the theory. See Alan Bryman. Computer appreciation. We are making a very big assumption here. The assumption is that you are computer literate. You do not have to be a computer guru in order to use statistical packages. Nonetheless, knowledge of computer operating systems is desirable. The skills you need are within the neighborhood of what we listed below. As a beginner, you should be able to 1. Put on the computer. 2. Open a worksheet. 3. Create a file. 4. Save a file. 5. Retrieve a file. 6. Print a file. 7. Use the keyboard. 8. Use the mouse. 9. Have knowledge of what statistical tool you wish to use. For items 2 and 6, you need to use the mouse to click. No special skill is required. What you will discover about the computer is that the Windows environment is interactive, so even when it appears you cannot go further, the help window will come to your rescue. Coding the data. The data file of the package you are using is divided into rows and columns. The interjection of these rows and columns creates cells in which numerical data can be typed. A typical data file appears like below: 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. The rows and columns are numbered serially, and there are several rows and several columns on a worksheet. The boxes are called cells. By coding, we mean specifying what figure goes into what cell for which variable. Let us use a typical questionnaire to illustrate coding technique. Questionnaire. Designed to measure the relationship between ethnicity and voting behavior, not in details. Question 1. Age: 16 to 25, 26 to 35, 36 to 45, 46 to 55, 56 and above. Greater than 56. Question 2. Religion: Christianity, Islam, traditional, others. Question 3. Ethnic group: Yoruba, Hausa, Igbo, others. Question 4. Occupation: employed, unemployed, students. Question 5. What party do you belong to? AD, APP, PDP, no party. Question 6. What party would you vote for in the next election? AD, APP, PDP, no idea. You should know that in question 1, age is measured on interval scale, but by grouping the respondent into age bracket, you have reduced it to an ordinal level. Question 2 to 6 are all measured on normal scale. Your coding guide will appear as follows. Question 1. Age: 1 is equal to 16 to 25. 2 is equal to 26 to 35. 3 is equal to 36 to 45. 4 is equal to 46 to 55. 5 is equal to above 56. Question 2. Religion: 1 is equal to Christianity. 2 is equal to Islam. 3 is equal to traditional. 4 is equal to others. Question 3. 1 is equal to Yoruba. 2 is equal to Hausa. 3 Igbo. 4 others. Question 4. 1 is equal to employed. 2 is equal to unemployed. 3 is equal to student. Question 5. 1 is equal to AD. 2 is equal to APP. 3 is equal to PDP. 4 is equal to no party. Question 6. 1 is equal to AD. 2 is equal to APP. 3 is equal to PDP. 4 is equal to no idea. Now, assuming you pick the first questionnaire already filled and returned from the respondent, and the person is 37 years old, a Muslim, a Yoruba man, employed, a member of AD, would prefer to vote for AD in the next election, then you will feed in the data into your data file on the computer. Thus, figure 15.1 will become V1, V2, V3, V4, V5, V6, 1, 2, 3. V1, 3, V2, 2, V3, 1, V4, 1, V5, 1, V6, 1. Notice that the title of the column have been changed to V1, V2 to V6. What we have done is define our variables, that is, give them names that the computer will use to recognize them. Instead of using V1 for question 1, you may decide to use Q1. It is flexible. Just click on Define Variable and the dialog box that appears will be interactive. You must also specify the value labels and the column size of each of your variables. All these are contained in the dialog box. Just click as desired. Now we want to assume that Now we want to assume you have treated all your returned questionnaire and that you have keyed in the data into your data file, figure 15.2. A very important information at this stage is that you should save your working files as you go along. Give it a suitable file name that you can easily remember. Selecting statistical test. This stage is the most technical stage in the sense that the computer operates on the principle of garbage in, garbage out, GIGO. The computer does not understand what you intend to do. You must instruct the computer accordingly. If you desire to run a t-test analysis but you wrongly click on regression, you will get a wrong output. This is why we emphasize that a good knowledge of what statistical test you wish to carry out in order to test your hypothesis is very important. This must be decided even before you sit in front of the computer. Once you know what test to carry out and what instruction to give to the computer, you have completed your own side of the contract. The computer will carry out all the instructions as required. You don't need to know the formula for calculating regression coefficient. Just click Statistics or Analysis. And from the list of tests that comes out, pick Regression. The dialog box that drops out will prompt you to specify what your dependent and independent variables are. After specifying all those, click OK and your regression output will come up in few microseconds. Save the output file or print it as desired. Space may not permit us to go into details in this medium, but the necessary skills you need in carrying out a computer statistical analysis have been provided in this lecture. All you require now is a computer system and a good statistical package installed into it. There are quite a number of computer statistical packages, but the one that is most useful in social sciences is the statistical package for the social sciences, SPSS. The latest version of the package is what you need to install on your system. Summary: computer statistical analysis is very useful in handling a large volume of data. It is faster and much more accurate than the manual calculators. A knowledge of computer operating system and the kind of analysis you want to run is important. The correct instruction must be given to the computer because your input determines the output you get from the computer. This is the end of Studies section 15. Thanks for listening.